Good afternoon. It's Helicopter John. Just want to take a few moments this afternoon to show you all the modifications I've made to my Shopbot PRT router. It's a 48 by 96 machine, and we've installed all new electronics in it, new servo drives, Gecko 203Vs, and we've also installed a Super PID speed controller, and we've used pretty much all PMDX electronics in doing this conversion. And what I'd like to do now is show you some of the modifications we've done, and also the drawer and other items that we've done in this conversion. One of the first things I'd like to show you is the drawer that my brother built for me, and it fits underneath the support beam here of the Shopbot router, and it's got a slide out drawer along with this shelf and a little deal here to hold all your router bits and your joystick and tape measure, whatever else you might have. Then we're going to go down here to where the drawer's at, and if you look on the front of the drawer, it's got an LED on there, and this is for our Super PID spindle controller, and this will actually display the RPMs of the router and give you other update information. The drawer has full suspension glides on it, so it's pretty nice as far as working on any of the equipment you may need to in the future. I want to start off over here in the right hand corner, and this large board you see here is a PMDX 126 breakout board, and it has a couple other auxiliary boards on it. One of them is a PMDX 107, which is isolated speed controller that works in conjunction with the Super PID speed controller, and then of course that hooks to your front panel here on the display you saw originally. Also on the PMDX 126, I have what they call a smooth stepper that operates off of USB. Typically, most of your Mach 3 installations run off of parallel ports, and I have that option. If I want to, I can run through those parallel cables inside those isolation tubes, or I can run it off of the smooth stepper, and I've chosen to run it off the smooth stepper. And then all of these connections you see on this side have to do with either your emergency stop or your other various inputs to your control board. We also have your proximity switches hooked up here that will control your table as far as not running into the or off the gantry and that type of thing. So these are all safety features that are hooked up to the board. The next thing we have here, and this is another PMDX item, and this is the PMDX 133. These are motherboards, and you actually see two of them here. Each one of these motherboards will hold up to 3 Gecko drives, and currently I have 4 Gecko drives on here, and if I want to put a 4th axis or something else, I could hook that up to this, and I still have one spare over here on this one. But they're daisy chainable one to another. If you look on the front of these, I have some cooling fans, okay, and also have heat sinks on these, and they make a little bit of noise, but I'm going to turn it on here just for a second so you can see that I have cooling fans that run there to keep those cool. Also on the very back, I have another exhaust fan which sucks any of the hot air out of the drawer. Next thing we have here is the power supply. This is a 70 volt power supply, and this is what gives all the powers to the Gecko drives. The next thing we have over here, which also has a cooling fan on it, these are solid state relays. I have one that operates the dust collector, I have another one that operates the vacuum pump, and this also has a cooling fan on it, and these also have heat sinks on them. It's very important on these solid state relays. They're rated at 25 amps, but anything that you run on them over 10 amps has to be heat sinked. So I not only have a heat sink on them, but I've got the air blowing over them, and I've actually fabricated a little plastic cover on there to give it like a little tunnel to blow the air through. And back here is my power supply. I have certain things in this cabinet. Some of them are 5 volts, some are 12 volt, and I have those run to the individual switches in order to control those particular items. And we also have 2 switches here. One of them is to turn the computer on, and the other one is to turn on other miscellaneous items within the machine. I think this just about covers all of the equipment that's in the drawer, and we'll go ahead and shut this now, and we'll move on to some of the other features that I've incorporated in the Shopbot. The next thing I would like to show you is what we installed in the way of proximity switches. Proximity switches, in my opinion, are a lot better than your regular mechanical limit switches, because the mean time failure is a lot greater on these. And what happens is when this little yellowish orange thing gets close to where this aluminum plate is, it'll actually give it a fault and turn the router off. So if it goes too far, it'll turn this off. These can also be used for homing switches, which we'll see in a minute. Now this is the one for our x-axis. I'll show you the one over here. This is for our y-axis. And here's the associated plate for it. Okay? And then lastly, this is the z-axis. And you can see whenever this yellow, whenever the plate comes up and gets in front of the yellow, that it'll actually it'll fault out, and it will tell your z-axis is homed or what have you. Now we're going to do a homing. So that was the z-axis. It's the y-axis. That's the x-axis. Now you can see both the x and y axis are zeroed, both in the machine and in the other coordinate system. And the z-axis will be set when we do the top of the part. Now we're going to go to the XY0. Now we're going to go to the park position. Park position is a position that's set up in the 2010 ScreenSet. It's basically to move the gantry out of the way when you're installing new parts for machining purposes. Now we're going to go to the tool change position just by clicking on the TC. This brings the router to position where you can easily change the tools. The next thing we want to show you on my Shopbot router is my dust chute. And what I've done, I've made like a top plate out of plexiglass. Then I have a vertical bracket here with a slot in it, and I use that for setting the height of the dust chute. Okay, and I can move this up and down to get various heights. I can also accomplish this by different size and length brushes, but I'll show you more about that in a second. What we do on the bottom of our plate, we have these quarter 20 bolts, and up inside the plexiglass we have magnets, and we put this up here. It snaps in position, and when you want to take it off, I've made these tabs out here at the edges where you can very easily pop it right off and put a different size brush on. And then of course when you have the other brush on, you may want to raise or lower your vertical bracket to give you additional adjustment if needed. The next thing we're going to show you is how we use the laser pointer to select the X and Y 0 axis of a corner, and we'll move it into position. Once we have it located at the position, then what we're going to do is click on the screen for the laser XY 0, and then what it'll do, it'll move the router, the center of the router bit to the very corner to your datum point on the XY 0, and I'll show you the screen next. Now we're going to show you how this laser XYZ0 works on the computer. If you look now, we're at plus 164 Y 4 point whatever. Okay, and whenever we press this, what it's going to do is it moves that over to the corner, and when it gets to the corner, then it's going to re-zero that, so you'll establish your new XY0 coordinates. Of course, you heard it run over there, and now what it's done, it's set that corner. So now you're ready to machine your part, with the exception of setting your Z0, which we'll show you how that's done in a second. Now if you'll notice, once it's moved to the XY0 datum, it also zeroes your DRO, so you're ready to start machining. All you have to do that now is set the top of your part for your Z-axis, and you're ready to go. Next thing we're going to do here is to establish our Z0. We have a touch-off plate here in our Mach 3 2010 screen set. We have it set up where it calculates the difference in the thickness of this, so it'll establish the top of our part. So now it's going to come down, it's going to touch it one time, it's going to back up just a little bit and come back down and touch it again. Now it's established the top of the part, or the Z0. So now we have the X and Y 0 and also the Z0. When you're doing a touch off, or you're going to use a single tool, you use the single chevron. If you're going to use multiple tools, then you'd use the multiple chevron. And if you look at the Z, my safe Z is set at 2 inches, so after the tool is set, it'll return to that setting. The next thing we'd like to show you is a simulated multiple tool change on the Shopbot. We're going to take our fixed plate, we're going to position it underneath the bit, and then we're going to hit our double chevron on our control software, and it's going to move down at a given rate, maybe 10 inches a minute or whatever, until it touches. And it's going to back off maybe 100 thousandths, and it's going to come down 2 inches a minute and touch off there. Now it's going to move over to our fixed plate. It'll do the same thing on the fixed plate, come down at 10 inches a minute, and once it touches, it'll back off about 100 thousandths, then it's going to come back and touch again. Now it is actually returned to where we did the touch off on our part. If we look over here now, we have an indicator that says start spindle, then press OK to continue. Okay? Now, in that operation, we would have went out and actually cut some material, did some things, but then when it's finished doing the first cut, it's going to bring it back to this tool change position. Now we're going to change to a different tool, and it will be a shorter tool, and what it'll do, it's going to go over here to the fixed plate, and it's going to touch off that tool, and it'll decide what the difference in the height of those tools are and normalize that so it comes to the same Z position. Now we're going to change the tool. Now we have a different tool in here, has a different height to it, and put on our dust collector shoe, and we can adjust this to the proper height on the shoe. Now if we look over here on our screen, it says press cycle start after tool change. Changed our second tool. Now it's going to take that tool down and set it on the tool setter. And it'll know the distance between what the first tool was and what the actual length of this tool is, and it'll normalize those figures. Now it's touching it twice. Now that the second tool has been normalized, we're going to tell it to start up again. Turns on the spindle. It'll do your cutting, whatever you're going to do. And whenever it's done, it'll go to a certain position and it'll stop the router. So that's how we use the 2010 ScreenSet to do multiple tool changes. Okay, the next thing we want to talk about a little bit here is the control, and I've elected to go with a smooth stepper, and in conjunction with my PMDX 126 breakout board, and of course it allows for a lot smoother operation of Mach 3, and it also allows me to use my laptop here instead of using an old desktop with parallel ports on it. I can run it in Windows 7. I'm running in XP compatibility mode, which is nice, and so far it's run flawlessly in using the smooth stepper hardware and software. The next thing I'd like to show you is our 2010 screen set that we're using here on our Shopbot router. It comes standard with a lot of great features, and one of them that I really like the most is a semi-automatic tool changer that we've already talked about. It has a lot of drop-down menus that you can work along the way here. If you want to see options, it has a jog menu. It's a tool change menu. It's an offsets menu, a limits menu, and a settings menu. Of course, we'll go back to the run. There was a couple things I wanted to add to customize it slightly, and I put this this row of buttons along the side, and the one at the top here is for my vacuum pump. You can hear it come on. The little light lights up. If I want to turn on my dust collector, okay, I can do that. And when the spindle's actually running on the machine, this will light. And anytime I'm using my touch probe, this will light. And I can go into, I can jog in continuous mode, and the green light will be lit. And then here in the continuous mode, I can set the amount that I want to move, and then that's the jog rate. Now I can also go into incremental mode, and then whatever number I have down here, it'll cycle. Okay, on incremental cycle, each time I click on that, you'll see that it changes to a different amount. Like this would be 1 inch, be 100 thousandths, 10 thousandths, 1 thousandth, 1/10. And then let's go to XY0. If you're working on a part and you want to take it down to the very corner of it, where you've got the XY0 established, you can go there. And we've already talked about the laser XY0, which is real handy in setting your parts. And then I've also put a larger reset button out here, and there's a couple of these that are already on the screen set. If you look up here, this is where he has the reset button, and then your associated light is down here. Okay, and then if you look at the probe active button here, this is the probe active over, a little larger light, a little easier to see. But those are the few minor changes I made to it, but all in all, it's been a great tool. I really like it, and it's a super buy at $20. The next thing I want to show you is how we use our vacuum pump here. I make these LED edge lit signs, and I make them different sizes. And what I've done is manufactured a fixture plate. And if you'll look at the plate here, we've cut grooves in here, which the vacuum goes in. And here's the vacuum port, and then it goes out through a vacuum hose, and then down here to our vacuum pump. And what we'll do, of course, this sign has already been cut, and this is just a scrap sign here, but we'll lay the material onto the fixture plate, and then we'll come over to our computer, and we'll have that in it'll actually be in the program to turn on the vacuum pump. And we turn the vacuum pump on. I'll turn it off here again so you can see it pull it down. If you watch real close here, you'll see it pull it down. And of course, this is tight, and then you can do all your machining, and you're all set there as far as that goes. The other thing that I did when I machined this surface, I actually I took the whole top of it and machined it flat prior to putting the slots in it. That way, whatever you put on it will lay flat, and you'll have a nice fixture. And I also use this gasketing material, and it's a 1/4 inch wide material, but I actually cut the hole about 270 thousandths, so it's a little wider, and it has adhesive on the back of this, and I only cut the slot about 100 thousandths deep, and that way it gives some cushion there whenever it actually pulls down, that you get a good seal on your vacuum. The last thing I want to show you here is how many inches of vacuum this will draw, according to our pump, of course, and gauge. It's sitting about 27, 28 inches, which is really good as far as the vacuum is concerned. That's why it holds so good with your machine. That is just a regular gas vacuum pump, and it really works well for the operations I've done with it so far. This is our Harbor Freight 2 horsepower dust collector. In addition to that, we have a chip collector, and the chip collector is made out of a Brute heavy-duty trash can. Has a Venturi inside of it, and basically your router chips come down through the hose, go into the chip collector, out of the chip collector into the Harbor Freight 2 horsepower dust collector, and it grabs all of the dust, and the chip collector gets all the heavy duty particles. Well, I think that about winds it up for the Shopbot. I hope you've enjoyed all the information I'm sharing with you here to give you an idea of how you can convert your Shopbot, if you so desire, to a Mach 3 setup, and all the associated electronics and the different things that I use mine for here at helicopterjohn.com. Here again, thank you for watching, and that's how we do it at helicopterjohn.com.